Good morning, again. My name is Sean Osterwise, and I am a student in ME 3210, Design and Manufacturing, Section B. In the next 10 or so minutes, I will be presenting on Project 3. Project 3 is all about the wide variety of design and manufacturing topics addressed in the course thus far, including tools, techniques, models, processes, strategies, and so on. These topics are open-ended and can be pulled from any of the materials we have available in the course, minus the post-lecture selected topics that are intended for Project 4. Because design and manufacturing covers a lot of material, I've been requested to pick my top 5 topics that I like the most, tell you all about it, and why I chose them. So, without further ado, process number 1, gravity casting. In casting, liquid material is poured into a mold. Gravity is the only force sending liquid throughout the mold, as opposed to centrifugal casting and pressure die casting, which both use a light to moderate pressure. The material solidifies either through cooling, as with metals, or through a reaction, as with thermosets. Casting is different from molding due to the low viscosity of the liquid. Some casting processes use sand or a similar material to form a one-off mold, while more expensive repeatable techniques use metal. Gravity casting has a really long history behind it. I chose it because it also came up in art history ID 2241 as a method of making statues and sculptures out of metals like bronze and copper. Each statue was unique as sand or clay molds were often used, and those break upon removal. They also used a lost wax molding process, which involves making the statue out of wax, packing clay or sand around it, then heating it to harden the new clay mold and melt away the wax, which I think is cool. Capabilities and limitations. The gravity casting method uses a lot of material and often has a lot of waste. Material in the runners and leaking into gaps must be cut off from the final cast part. Sometimes that extra material can be melted and recycled, but it depends on the properties of the material and the properties of the cast. Also, sand molds and molds of other less permanent materials can only be used once. Sand molds have a rougher finish than metal molds, and sand molds can't achieve nearly the level of detail. That's why the whole wax method was used back in the before times, to reach that level of detail to impress the emperors and the elites. Also, for the more permanent molds, the molded parts have to have some direction to them, i.e. no overlapping. The two sides of the mold have to move straight apart from each other so that the part can't be removed. That's what gives the sand molds their advantages, as the sand molds don't have that problem. The mold is going to be broken anyway. It can be removed from whatever part is made. Process number 2, cutting. In cutting, a material sits on a die, and a punch pushes through the material until the material shears along the outside of the punch. There's really 3 types of cutting. When the material shears along a line, like from one edge of the material to the other, that is shearing. Think scissors or a paper slicer. If the material shear is a closed shape, it depends on what part is the usable piece. If the inside of the shape is to be used, the process is blanking. The removed piece is the blank, and the rest is the strip. Think hardware like washers or gears. If the outside of the shape is the usable piece, then the process is punching. The removed piece is the slug, and the remaining stock is the part. Most flat pieces with patterns of holes, like vent grills, are made from punching. Paper is often punched with a 3-hole punch to attach binder rings. I chose cutting because cutting is simple and a very flexible operation. Beyond shearing, blanking, and punching, there's technically also cutoff, parting, slotting, perforating, notching, semi-notching, trimming, shaving, and fine blanking. All of these techniques are some combination or adaptation of the main 3. For example, shaving is just shearing with a very fine cut, used as a finishing operation to smoothen and straighten edges of parts that have been previously cut. Capabilities and limitations. Shearing, blanking, and punching processes are great for thinner, flatter material. These processes are capable of zero waste, as the full area of the material can be used or recycled. Shearing processes are also faster than any other cutting process, making them very efficient. These cutting processes, however, don't work for thicker materials, harder materials, or shorter lengths of materials, and can damage the tool or part if misaligned. Process number 3, boring. Boring uses a single point tool against a rotating work part. Boring is performed on the inside of an existing hole as opposed to the outside, which is called turning. Machines that bore are called boring machines or boring mills. Boring machines can be vertically or horizontally oriented. In horizontal boring, the setup can be arranged in either of two ways. The first setup is one which the work is fixtured to a rotating spindle and the tool is attached to a cantilevered boring bar that feeds into the work as seen on the left. In the second setup, the tool is mounted to a boring bar and the boring bar is supported and rotated between centers as seen on the right. On the left, the tool moves into the part. On the right, the part moves into the tool. In vertical boring, the part is clamped to a work table that spins, and the bore moves down into the part. Vertical boring is used for much larger parts, and work tables exist up to 40 feet in diameter. I picked boring because I associate the term with the tunnel boring machine. On first glance, one would assume the machine functions like a large drill. In reality, the machine functions similar to the first horizontal setup, where the boring tool is fixed to the rotating front of the tunnel boring machine. Photographed is one of the boring machines used to carve away the Channel Tunnel that connects England to France. This tunnel opened in 1994, but the type of machine shown in the picture was really invented in 1845 with the Freyas rail tunnel between France and Italy through the Alps. Capabilities and limitations. The boring machine conceptually is versatile and can be designed to accommodate any large diameters. For example, the tunnel boring machine can bore large distances with diameters designed to fit multiple cars or trains without much seismic disturbance of the surrounding area. However, large boring machines have very limited use cases and often exist to be used one time. Smaller diameter, mass producible jobs are also better accomplished using a vertical turret lathe instead of a boring machine. Topic number 4, lean manufacturing. Lean manufacturing is a 5-step procedure to make money manufacturing. Step 1 is to identify value, i.e., what do the customers need? If nobody wants it, why try to sell it? Step 2 is to identify the value stream. Make a plan to turn raw materials into something you can deliver to the customer and identify ways to reduce waste. Step 3 is to create flow. You have a plan, put it in action. Ensure the products are supplied in a way that meets the demand. Step 4, establish a pull to ensure there is always demand for your supply. Avoid a surplus to avoid wasting time and resources. Step 5 is to achieve perfection. Keep improving the process, eliminating waste where possible. I chose this topic for its simplicity. It is functionally a tutorial checklist on how to be effective in manufacturing. Capabilities and limitations. Lean manufacturing is great at increasing production and customer satisfaction while reducing cost. However, it is generally inflexible for short-term changes and can lead to workforce resistance. It may also be expensive to implement initially. Process number 5, injection molding. Injection molding is a lot like gravity casting, except a pressure is applied to the liquid and the liquid is usually more viscous. The polymer liquid is heated to a highly plastic state and forced to flow under high pressure into a mold cavity where it solidifies. The molded part, called a molding, is removed from the cavity. A lot of plastic products are made from injection molding, including all plastic bottles, bottle caps, and all Lego bricks, which is why I chose this as my last topic. Capabilities and limitations. Complex and intricate shapes are possible with injection molding. The challenge in these cases is to fabricate a mold whose cavity is the same geometry as that part and allows for part removal. Gravity casting has the same issue, the part cannot have overlapping sections.